Hi, welcome back to Element 14 Presents. My name is Mark. Today I'll be building something from my to-do list for a very long time. I will be building an FM radio. And I'm not just going to build any radio because I will not be using transistors. I will not be using software-defined radio if that's what you're thinking. And I also won't be using integrated circuits. Well, kind of. I'll get back to that in a minute. Instead, I'm really going to build this the old-fashioned way using electron tubes. Now regarding that disclaimer, I will be using a voltage regulator because, why not? But you can change that if you want. And I will be using a chip to decode the stereo signal that is transmitted with the mono signal, and so we have stereo output, but that's completely optional and you can leave it out to really have a transistorless radio. Instead, we'll be using electron tubes. So let's get started. I found a kit on the Chinese website that includes everything I need to build an FM radio with tubes. At least that's the idea. So I decided to order it and check it out. It came with a nice capacitor that we can use for tuning. Of course, it has all the electron tubes. That's what this was all about, and that's perfect. So we're going to use those. It came with some nice coils for the frequency stages for the filters, also perfect, and it came with all the discrete components. So nice, right? Wrong. So here's what happened. It also comes with a manual, and when you take a look at the manual, everything is in a very nice language, but it's not one I speak. I mean, I speak German, English, and Dutch, but I don't happen to speak Chinese or Mandarin or whatever this is. So I use Google Translate, but that will only get you so far. And I discovered a few errors in text, and there's not really a very nice description on how to adjust the frequency stages, how to do that. So this manual, well, kind of sucks. It was useless. So let's put it aside. It also came with a schematic. Now, here's what part gets interesting. Because I tried to reverse engineer the schematic with the PCB that came with the kit. And as expected, there are some reference designators on here. There are some that don't match, and there are some components that don't even appear in the schematic. So I tried to reverse engineer and make a new schematic, but I stranded halfway because so many changes between the schematic and the PCB that I cannot do a reliable build. At least I'm not going to put in my effort. So I decided to discard this one, and I will also discard any components I don't need. I will be using the tubes, the coils, the capacitor, and maybe some discrete components, but all in all, I will make a complete new design. Let's design a radio from scratch. Okay, so I had to redesign the whole radio because there were quite a few inconsistencies between the PCB layout and the schematic that were provided in the kit. So I decided to do a complete redesign. And I started with the oscillator and worked my way around the schematic from there. I'm not going to go through each and every block that I drew because that will take another hour. And that's beyond the scope of this video. But if you do have questions about the schematic, feel free to visit the Element 14 community at the project page and ask me questions there. For now, we'll concentrate on the block schematic below to explain how this radio works. Well, basically, we have our antenna signal that's amplified and filtered by a band filter. We filter that range in about the range that we want to receive radio stations from. So that's 80 to 135 megahertz. The signal coming from the band filter will be mixed with an oscillator signal. Okay, so the oscillator oscillates at a frequency same as the radio station we want to receive, plus 10.7 megahertz, which is similar to the mid-frequency stages that we go to next. because we have our band filters set at 10.7 megahertz. It's filtered, amplified, filtered, amplified, filtered, amplified, and so on. We do that 3 or 4 times until we reach the FM detector. And in the FM detector, we extract the original audio from the carrier wave. So our original audio signal, the music or whatever we're listening to at the station is filtered out. And that's then fed to a stereo decoder, which is optional. You could bypass it, but let's use it. The stereo decoder extracts a left and right channel if present in the input signal, extracts it to left and right, so we have a stereo signal which can be amplified and fed to a headset or a amplifier to your liking. All of this, of course, I had to redesign in a PCB, and that looks like this, although my PCB is black and the silkscreen in our software is pink. As you can see, all the blocks are present as sections on the PCB by these yellow markings. We can put some metal shielding around our tuner and oscillator part for stability if needed, but that's something we'll decide when I start doing the adjustments later. And the PCB in 3D will look approximately like this. We have our variable capacitors or tubes and coils. The coils are though different in the picture than in reality because I only had these 3D models available at the time. But it will give you a good impression of the PCB. Okay, so with a new PCB and a whole bunch of new components for this design, we will be reusing the tubes and the coils. Let's start assembling. We'll start with the small components first and move our way up until everything is assembled. Now almost everything is in place. Let me place the final resistors and then we'll start soldering. So just follow the part list and the assembly drawing and you should be able to find out which resistor goes where. Now let me flip it over. Now, this is how I usually do it. And then I start soldering one lead of every component and then see if everything is still placed correctly, and then I solder the final lead. So that's that. One more. Now everything is connected with at least one lead. I flip it over and I take a close look to components, and like this one, it came out, so I can replace it and see if its adjustment is needed. So far, well, not bad. I think it's good enough, so let's solder up the remaining wires. Of course, later I will do an inspection of all the soldering under a microscope to see if I have any failures in soldering or short circuit. So that's it. Now let's cut some wires and we'll see if we forgot any pins. I know you're supposed to cut the wire first and then do the soldering, but you know, I don't mind doing it this way. It's just easier for me. And there we have it, some nice soldering, and then this is what it looks like with all the resistors assembled except the two power resistors that will go there later. I will do those a bit later. Okay, so let's move on to the capacitors. So I have a lot of capacitors in place. Let me put a final few. C37, that goes in there. Now we have C1. That will go right there. We have C22. And then 2 left, which go to the stereo amplifier or the stereo decoder. 46 and 47. So those are all the regular capacitors. Of course, we move on to our electrolytic capacitors. Let's start with the smaller ones. So we have 1000 microfarad capacitors, 41 and 42. So this one. We have our big capacitors. Let's see, 100, 100, 100, and this one is 120, 120. Okay, so they each go there. Oh wait, put them right or blow them up. So that's where the capacitors go. We have 1 microfarad that will go here, the stereo decoder. Okay, again, first we do one leg, one wire, and then the other one, so we can still align the components if needed. Okay, so I still need to solder the second leg, but I will already add a few new components, which are the coils that I have for stable power of the tubes. Okay, so we already come very far. Let's put the sockets for the tubes. Yeah, as soon as I flip them over, they might fall off, but I have a trick for that, don't worry. So, the trick I have is to simply solder one leg on the top side. Or two. Anyway, that way they won't fall out when I flip over the board. So all that's left is a variable capacitor, and we have our helicoils which go in the middle. But before I do that, let me solder up all the loose components at the bottom, because not all wires are yet connected. So let's start with that, and from there on we'll move to the coils. So let me put this aside. Okay, so to put the coils, there are two types. One has 4 pins and the other one has 5 pins. And one thing you need to know, there's a marking on there on the coil, primary and secondary. You're going to recognize because one has a 10 picofarad capacitor and the other one a 22 picofarad capacitor. Now it's important that when you mount it on the board, it's important that the side that has 10 picofarad capacitor goes to the terminal G and E. So 10 goes to G and E, and 22 goes to B and P, like so. Okay, then when you solder them up, you need to put the cap over it, because this way it's easy to align them dead center. Okay, we're almost done. We need to put in the radio tubes, hook up the power supply, and we can start testing. But we still need to mount one very important thing for us to be able to select a radio station you want to listen to, and that's our variable capacitor. And we're going to mechanically mount that right there and then hook up some wires. So I prepared some screws. I'm going to put those in there, like so, almost like so. And then we need to connect a few wires. And there you have it. One radio PCB. So let's hook up the power supply, do a little smoke test to see if everything's fine, and then we will start doing the adjustments. Of course, once I do the smoke test, I will install these caps. For now, I decided to leave them off, so it's easier for me to adjust everything. So before I plug in the live wires, I will be doing some testing of my secondary supplies, and without having to connect the live wire with the risk of doing a very serious smoke test, I'm using this nice multi-comp power supply. It has dual output and it can supply 5 amps and 31 volts on each channel. I'm using one channel, and right now I can set it, and the perfect thing is I can limit the current supply. In case there's a short circuit on the board, it will not drain the maximum current and I can save my components. So let's adjust that. We'll set the voltage to 9 and the current, let's limit that to 100 milliamps, like so. Yep. And then I'm just going to inject that to my 9 volts test pin. And now the 9 volt circuit has power, and I can see the limitations. The current is drawing is only 60 milliamps, which is fine, so test completed. Okay, now this test turned out to be a non-smoke test, which is good. Let's move on to the next test where I will be applying the live voltage. So I'm slowly going to turn off the voltage to do a first smoke test. Now we're at 50 volts, 60, 100. So far so good. So far so good. Now we're getting somewhere. 220. Okay, so the first smoke test is a non-smoke test. That's good. Now with everything in place, the transformer hooked up, we did a first test and it didn't go up in smoke, thank God for that. So let's move on to tuning. Alright, this brings us to adjustment. Well, the first thing I did, I removed the oscillator tube. All the remaining capacitors are in place, and I removed the oscillator tube so the oscillator won't work. Perfect. So we can inject 10.7 megahertz from a function generator, a sine signal with an amplitude of about 800 millivolts, which should do it. Then we inject that to our first stage. We connect the oscilloscope on the output of the stage, and then we just start adjusting the core until we see a maximum output on the oscilloscope. And we do that same trick for each stage. So we hook up the function generator to the input, the oscilloscope to the output, and we adjust it to the maximum output. Then we need to, when that is done, we need to tune the oscillator. For that we need to reinsert the tube, wait for it to heat up, and then it'll start oscillating. Okay, so there are two ways of fine-tuning this radio. You can set the oscillator to a frequency of the station you want to listen to minus the 10.7 megahertz of the mid-frequency stages, or you can set the oscillator to the desired station plus the 10.7 megahertz. So you tune to the upper band. Okay, so after inserting the tube, we're going to adjust the oscillator. It should be a frequency range of your desired station minus 10.7 megahertz if you want to tune to the lower band, or it should be your station plus 10.7 megahertz if you want to tune to the upper band. So let's take the lower band, which means if I want to listen to 100 megahertz, I should see an 89.3 megahertz coming from the oscillator, and you can check that with your oscilloscope. You can adjust it to shift the whole frequency range by adjusting C44 until you have the desired frequency. Now with the oscillator working properly, disconnect the oscilloscope, and with the antenna attached you should hear a lot of noise coming from your speaker. Yep. One thing you need to do is the preselector, you also need to change that. Just change C11 until you have maximum output. There we have it. You can adjust the last FM detector until you have a very crystal clear sound. And then you need to adjust the stereo decoder. That's the last step. Just turn the dial until the LED goes on, so you know you have a stereo signal. And there we have the stereo signal. The LED doesn't turn on, but that's my fault. I think I soldered it in reverse, so that's why the LED is not working, but I can hear the stereo sound. Let me lower the volume. I will change that LED later before I put it on a nice wooden pedestal or box. And of course I will put a cover over it because I don't want anyone to get electrocuted when they take a look at this nice piece of art. Well, with the PCB ready, the radio tuned, is all functional. I will need to mount it on a nice wooden pedestal or a nice wooden cabinet or plexiglass. Remember, it's your responsibility to make it safe. This is all I have for you today. I hope you enjoyed it. I'm sure I did. For me, this was brushing up on analog technology, something I learned a very long time ago, and I really enjoyed this one. If you want to build your own radio, you can visit the Element 14 community. There's a project page, and you can download all the information you need to build your own set. If you have any questions or comments, you can leave them at the project page, and I'll do my best to answer each and every one of you. Until then, I'll see you next time.